We want to introduce you a Qing Dynasty bronzeware, as it is a representative product in Qing Dynasty. This is a bronze weight which is for measuring weight use. According to the MarketFit website, it has 7 cm height, 246.5 gram weight, and is unearthed in the mausoleum of first Qing Emperor. An additional chemistry knowledge is that bronze is a copper alloy which can resist a corrosion more effectively than poor copper. So, because of this bronze weight is made by bronze, it is kept almost intact when it is unearthed. It is now collected in Emperor Qin Shi Huang's Mausoleum Site Museum, and the museum collection serial number is 002838. This bronzeware side face has multiple facets. Let's count the facets, shall we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So, there are 17 facets in the bronzeware side face. Each facet is marked with different inscriptions. According to Li 2017, the content of the inscriptions is consisting of the first emperor's 26th year edict 221 Bs, and the second emperor's Qin Ershi first year edict 209 Bs. Li 2017 also stated that the inscriptions can verify the Qing Emperor unification of weight measurement. So thanks to the bronze material, the inscriptions can be kept well to researched by the historian. On top there is a hole for the hook or rope. When users want to weigh, the weighing scale can hook or use the rope to type the suitable bronze weight hole. Although you cannot see the interior of the bronze weight through the 3D model, the bronze weight is hollow. Let's talk about the history of the Qing Dynasty bronze weight. A weight is a product when the social and economic development of a society reaches a certain level. After the Qing first emperor unified China, he issued an edict to regulate the measurement system of length, volumes, and weights throughout the empire in 221 Bs. Li 2017. This bronze weight is a product under the edict. Also, the edict marked in the side face at the side of this bronze weight is a prototype or standard for the weight measurement system. The regulation of the measurement system is the policy to ensure the Qing government can receive higher accurate amount of tests. If there is more than one measurement system, the transactions will be in a confused state. For example, a city attributes 1 kilogram gold in his measurement system to government, but this gold is measured as 0.5 kilogram in the government's measure system. Then the government does not receive enough gold. If every city has a similar situation, the government's national treasury will have a deficit. On the other hand, regulation of the measurement system is a way to display an authority of the government. Every people must follow the measurement system and issued by the government to pay the right amount of tax. If they do not follow the measurement system, the payment of tax may less than regulation and they will get punished. The material selection of these bronze weights might be a multifaceted consideration of Qing producers. In order to produce a weight that keeps for a long time, Li 2017 stated that Qin producers can choose stone, pottery, metal. If the producers want to use the stone to mass-produce weights that all have minimal weight deviation, they have to collect enough stones that all have similar weight too. However, nature may not have enough stones that meet the weight condition, and it is difficult to find those stones. The most challenging part is that the producers need to sculpture the stones into weights one by one. The processing is taking so much time, and the shape of weights may be different due to the skill of different producers. Then there is a large deviation between the products. Therefore, the stone is not a good material for mass producing. A pottery is a mix of clay and water which has a lower cost of material. It is possible to mass produce pottery weights. Due to its lower cost, the pottery weight is suitable for the common people usage. However, pottery's mass is lower than iron or bronze mass. It means that if a pottery product has the same weight as the bronze product or the iron product, its size must be bigger than those two metals. Then, Qin people will store a fewer amount of the pottery weight than an amount of the metal weight in the same storage space. On the other hand, pottery products are easy to be broken. They needed to be kept carefully, and this situation will increase the maintenance fee. Then, due to the technology, Qin dynasty may not lay the surface smooth road between cities. The surface uneven road can break the pottery products easily when the pottery products are delivered. Therefore, pottery is not a good material for storing and transferring. Metal like iron and bronze is a hard, enduring material for mass producing and safe distribution by the Qin government. Unlike stone, metal is a material that produced by similar physical and chemical composition. But using modificatory technique like Sumerlash, Qin producers can mass produce metal weights to ensure minimal deviation of each product. And unlike pottery, metal is hard and not easy to be broken. Among metals, Qin producers choose to use iron and bronze, which differ greatly in characteristics to produce the weights. The weight in the right picture is made of iron, while our weight in the left picture is made by bronze. And you can see that there is a plaque that's made by bronze on the iron weight. The bronze plaque has inscribed the edicts. Through this, you can conjecture that the Qin producers already have knowledge about the easy corrosion of iron, so that they inscribed the edicts onto the bronze plaque that is more enduring. This additional machining may increase production time, since the iron weight in the left picture is not kept well as the bronze weight in the right picture. Through both of the appearance, bronze weight is more enduring than the iron weight. Furthermore, the environment is also a major element for choosing iron or bronze. Raining and moisture can corrode the iron quickly, and this situation will increase the maintenance fee. Therefore, bronze is the most suitable material for mass production, distribution, and conservation. To create a copy of bronze products, Sumerlash is one of the methods that can choose by the producers. Here's a simple introduction about Sumerlash. There is a bronze weight which is an original model. You can see that it is U-shaped and it is empty inside. Also, there are some inscriptions on the model. So let's talk about how to complete the Sumerlash. First, we need to put some clay to cover the outside of the original model. Because of the feature of the clay, they will print out the inscriptions from the model. Then, a mold is done. What we need to do is to cut the mold and separate it in multiple parts, because it is easier for us to separate the model and mold. In this example, we will separate it in 3 parts. At this time, we can take away the model and combine the 3 molds back together. Then you can see the traces on the mold because of the cutting. So now we get a complete mold here. Next, we need to reverse the mold. At this moment, we need to hand a material which is matched the shape, but smaller, because we need to create a bronze product which is hollow too. Then we just need to pour the bronze solution inside the gap until it's full. Finally, we just wait for the solidification, then pull out the material that we've handled and take the duplicate product. The simulation is finished. However, LEED 2017 stated that the simulation is not a feasible procedure for copying the product. This method will create a smaller size duplicate product, because the molten bronze inside the mold shrunk while solidifying. To solve this problem, the size of the original model must be bigger than the standard model. Therefore, the duplicate products can match with the standard size. A historical artifact can tell us many things like the history, technology of casting, policy at that time, and so on. This bronze weight can help to prove the Qing dynasty's regulating of measurement system of weights and reflects the knowledge of the Qing producers. However, the findings of different bronze weights lead to a question. Although a bronze weight is a product of regulating the measurement system, it has multiple appearances that are not unified. We can assume that there were multiple processing fields in Qing dynasty to produce different kinds of weights rather than a single processing field concentrated to produce the weights. Anyway, the bronze weight is a valuable product. We should keep searching for more artifacts.